I don't know if dogs can be lucky, but I hope to prove to you by the end of this presentation that the Golden Retriever is the luckiest dog in the world. So keep that in mind as we move ahead. There are two purposes for this video. The first one is to demonstrate a whole host of mixing procedures, especially for small packets of cards. And you may recognize some or many or most of these. So we're going to go through and quickly kind of show you each of these. Now, one of the purposes for doing that is to randomize this packet of cards in front of you. So the second purpose here today is to demonstrate a most remarkable structure. So these cards, let me just turn them over. There's 8 of them. These 8 cards have a very, very special structure to them. And that structure is going to allow me to make a prediction now about the ending structure of these cards, despite the fact that we are going to use this 20-sided die to randomly choose a certain sequence of mixing routines. Okay, and let me tell you ahead of time what this structure will be so that we have it on record. Now, first off, 3 of these cards, as you will see, have been marked as bullies. So these are, kind of nasty dogs, bully dogs. And then 4 of them have been marked as nice dogs. These are good dogs. And then the Golden Retriever had no marking on it at all. Because it's a special dog, it will end up being the luckiest dog alive. So one thing I have observed with bullies is they never seem to bully bullies. They always seem to find some hapless soul, some nice person to torment. And so my first prediction is kind of an unfortunate one. My first prediction is that every one of the 3 bullies will find a nice dog to bully, to torment. And so that leaves 1 remaining nice dog, and that nice dog is going to be paired with our Golden Retriever. Now, why is this important? Well, these 8 dogs, as you'll see, are in the same obedience school, and at the end of every session, the trainer divides the dogs into pairs to work together. And those nice dogs are just praying to heaven that they'll have another nice dog assigned to them as a partner. And the bullies are wanting to be assigned to nice dogs to show their dominance. Okay? But what will happen, regardless of what choices are made here, by that random outcome, the Golden Retriever will be paired with a nice dog. The other 3 nice dogs will each be paired to a bully. Okay, so that is my firm prediction at the start. So let's get started. We're going to demonstrate these shuffles and mixes. And we're going to have a reason to stack left piles on top of right piles quite a few times. So to keep the tedium down, I thought we would just make that decision once and for all, and it'll make things move along a little faster. So why don't we say, if I'm going to toss the coin, of course, if it comes up heads, we'll stack the left pile on top of the right. And if it comes up tails, we'll stack the right pile on top of the left. So let's see how we did. I don't know if that was a fair, let's try again. Okay, there you go. It's come up heads, perhaps twice. So we're going to always stack the left pile on top of the right. Okay, so that's what this random outcome has told us to do, and we're going to faithfully follow what happens with these random events. Okay, so now we have to randomly choose one of these shuffles to begin with. 16, very good. Okay, so what is 16? Oh, that's a Bessey 2-2. Now, before I perform the Bessey 2-2, I want to point out that, maybe I'll do it over here, that some of these shuffles come in pairs. And it's because they're essentially the same except for some small variation, or maybe the cards are being stacked in a slightly different order. So let's agree that if we do one of them in the pair, that will count the other one as complete. And I can kind of talk through how you would do the other one. And that will keep our video from being any longer than it might be otherwise. Okay, so back to this, 16. So we're down here at a Bessey 2-2. Now, I apologize. If anyone out there knows the proper name for this shuffle, let me know and I'll get rid of my presumptuous Bessey name there. I just put it there for fun, actually. But so this is how it works. You kind of hold the cards in what's called biddle grip. And so since it's Bessey 2-2, you take the top, one at a time, you take the top card, 1, 2, followed by the bottom card, 1, 2. 1, 2 from the top, 1, 2 from the bottom. And you just do that until all of the cards have been moved from one hand to the next. So we'll go ahead and mark those two as done. The only difference with the Bessey 1-1 is that you just move one card at each stage. But they technically give you a different permutation, a different shuffle. Okay, very good. Okay, let's, 2. There we go. So we got a 2. Now this is an RC shuffle. R stands for row, C stands for column. I've chosen those names because they remind me that the stay stack principle is involved. Because if you've seen the proof of that, there's kind of a matrix involved at rows and columns to proving the stay stack principle. So for me, I call it the RC shuffle. And all it is you just deal out the cards into 4 piles. I think I might move our little coin and die over there so that I can use more of the pad here. Okay, and so once again, we have a 2. Very good, a 2. So we're going to, I have an arrow pointing to the right. So what that means is we're going to stack them in the order that we dealt them out. So let me point out that this is, we declare this to be 1, 2, 3, 4. If you imagine them lined up, that's what they would be, pile 1, 2, 3, 4, in terms of how they were dealt. So we're going to stack 1 on top of 2, very good, 2 on top of 3, and then 3 on top of the last one, okay? So that takes care of number 2, and because it's paired with number 3, the only difference there is you're stacking them in reverse order from what we just did. Okay, 4. We haven't done 4 yet. Very good. So 4 is a judicious RC shuffle. Okay, so this begins the same as an RC shuffle. The only difference is the order of the stacking. I call it judicious because technically you can't stack these willy-nilly and have control of what's going on. So this one is more complicated than the one we just did, but it's saying that pile 1, which is right here, goes on top of pile 3, 2 goes on top of 4, and then we're in this situation here where we have a right and left pile. So we always agreed to put, is it left on top of the right? Right. Left on right. Okay, so very good. So we can mark both of those as done. The other judicious RC shuffle, you're just stacking the piles differently. You're going 4 on 2 and then 1 on 3, kind of just the opposite. Okay, very good. 16. Oh, we've done that one already. 4, 3, 3, 17. Now, as you can tell, we may have a hard time finding a new shuffle that we haven't used. So if it gets bad enough, we may have to make an executive decision on how we finish the remaining shuffles. 17, here we go. So this is a pairwise transpose. And I gave it this name. I don't know if it actually has a name in the literature. So a transpose is where you switch the order of 2 things. So pairwise just means the top 2 cards are switched in order. The next 2 cards are switched in order. Move those up. The next 2 are switched in order, and then the final 2 are switched in order. Now, with an arrow to the right, we're going to stack them from first pile, third, fourth pile. We're going to stack them in that order. And so let's go ahead and mark those as completed. The other pairwise transposes, you just do it in the reverse order to that. So not a big difference. 8, very good. We got a new one. A manche under over. Okay, so what's a manche shuffle? Okay, so how this works is you push off the top card. Now because we got under over, you're going to do under first, then over, then under, then over, then under, over, under. Okay, so that's a very common shuffle. It's very effective in randomizing the cards when used in conjunction with other mixing procedures. So it's a very good one. The other manche is over-under, so you just start with putting that first card above or over the one that's in your left hand. Okay, so not a big difference there. Sorry about that. 9, oh good, so 9. We have a faro in. Okay, let me show you a faro in shuffle. So what you have to do here is you just have to split up the cards. This is the top half, this is the bottom. And just see, what is it? In. So in means the top card, little doggy that's moving, needs to go underneath or inside the other packet. So you do that by beginning with your first card on the right underneath the lowest card on your left, and then just perfectly interlace them. And so that is actually a faro in shuffle. Faro out is just where you have the first card on the right above the one on the left where you've cut to. Very good. Okay, I seem to always make the mistake of taking the cards out of the camera's view, and which is really getting frustrating because, you know, that could be a sign that I've done something sneaky. I guess I should just assure you up front that if that happens, it's pure stupidity on my part. But I'll try to keep it in camera the whole time. Okay, so number 1, LR, that's just the left-right shuffle. Okay, and then here we are in that situation. We agreed to do left on right. Excellent. So the LR shuffle is completed. Let's quickly get rolling here because, oh good, I thought it might take a little while to get a new one. Okay, so judicious transpose. Okay, so this is the same as a pairwise transpose. The only difference is the stacking is kind of special. So 19, so we're going to do 1 on top of 3 and 2 on top of 4. Here we are, left, right. So let's go ahead and put left on right. That's what we agreed to do. And I'll go ahead and mark those 2 as completed. The other one, you're just stacking them in kind of opposite order. 7, okay, 3, this may take us a while. 10, 12, okay, yes, we got one. 12. The Australian shuffle. Wonderful, wonderful shuffle. It's called the down under shuffle. Okay, so how this works is you take the top card is down, under, down, under, down, under, down, under, down, under, down, under, down, and then drop the last card on top. So that is the Australian shuffle. Now I do want to point out, if a person were to write out all of these shuffles in cycle notation as permutations, these are actually all distinct permutations. They really are. Well, one thing interesting about the Australian shuffle, it's the only odd permutation. The rest of these are even, which is kind of curious. Okay, so it's special in that way. Okay, that's the Australian shuffle. 8, we've done that. 11, yes, we got a new one. That's pretty surprising. But let's not drop the cards. That's not a helpful thing to do. Okay, Klondike. So we've seen this. If you've watched the Law of Attraction video that I made, I've used the Klondike shuffle quite a bit there. It's a very useful shuffle. It does a good job, and it's taking the top and the bottom cards and bringing them together. So it is mixing the cards in a way that most of these other mixing procedures do not accomplish. Okay, so let's go see 10. 1, we've already done 1. 14, yes, we got a new one. Charlier 1, let me explain this one. I have a video showing the Charlier shuffle. And the only difference here is instead of moving, you know, a group of cards each time at each stage, you move just one. So let me just show you. So that's the shuffle where you do top to bottom, bottom to top, top to bottom. Okay, so you move this one over, and then the bottom card here goes on top. The top card goes on the bottom over here. Top one goes on the bottom there. The top goes on the bottom. Okay, then bottom to top, top to bottom, bottom to top, top to bottom, bottom to top. Okay, very good. Lost my brain. I wanted to do it exactly right so people don't think I'm pulling a fast one on them. Okay, so let's continue on. We're getting kind of close to finishing these. Oh, why don't we do this? I'm not thinking. We're only down to 2 options. Okay, well, we have to make a decision. So heads, let's say, is the up jog. Tails is the 50% coat. Okay, we'll do the up jog first. That's this one right here. So we let chance decide that. Okay, the up jog. So we're going to go up. The even position cards are going to be jogged, moved forward, up. And then they're stripped out, and we're at that same situation of left and right pile. So we agreed to always put the left on top of the right. So there we go. So that is the even up jog. And as long as I haven't missed any, there's only one left. It's called the 50% coat. Coat stands for count out and transfer. Now I sure hope I'm keeping these blasted cards in camera. So 50% coat, this is where you do 1, 2, 3, 4. You count out or deal out half the cards, and then you drop the rest on top. So it's fairly simple, but it does a good job because it switches the top and bottom halves, but reverses the order of that top half before it becomes the new bottom. Okay, now I want people to think about what we've done here. So we used a coin as well, but we used a die to kind of randomize the way in which these cards were mixed. And the idea that anyone could know what this structure, anything, in fact, let me back up. The idea that anyone could know anything about the structure of this packet is unbelievable. Okay? So I made a prediction at the beginning. I said that there's 3 bullies marked, and we'll see that, and each of them will find a nice dog, unfortunately. And the golden retriever will be the only dog, who I think is nice as well, that finds another nice dog as a partner. So I call him the luckiest dog alive for that reason, because if he can do that while surviving all of this, then you know that's amazing. Now let me just point out, we could deal out the top. We could take the top 2, put them out. I could also Klondike shuffle pairs to the table. So why don't we let chance decide even that? So let's say heads, I'll just take them in pairs right from the top, 2, 2, 2. And then if it's tails, we'll Klondike shuffle them to the table. Okay, tails. Okay, so that says Klondike shuffle them to the table. There we go. Just like this. This is just Klondike shuffle. And the only difference here is I'm just using it to kind of create pairs. That's the only difference. Okay, so here we have our pairings, and let's check how we did. Now I may not reveal all of these at once. We'll just see. So I may hold off. That one's not so great. Okay, let's do this one first. Oh, okay, good, good. Okay, so I said that the bullies would be perfectly matched up with the nice dogs. Let's try this one. Oh, good. Thank heaven. Okay, so we got a bully matched up with a nice dog as well. I hope this one kind of saves me. So I'll have 3 out of 4, but oh, yes, yes, yes. We got a bully. I've drawn these little horns to emphasize that these are evil dogs. Unfortunately, he found a very cute, nice dog. So what that's left us with is, now, if you remember at the beginning, we actually had a golden retriever, right? We had a golden retriever, and of course you can already see the card, and I'm making this big reveal. So pretend you didn't see the card. We had the golden retriever, and I predicted that the golden retriever would be paired with a nice dog, and he is. And in fact, he's one of the nicest dogs, I think, that particular breed of poodle. So, so I want to once again invite the mathematical community to try to figure out what is the special sequence of 8 objects that would allow me to structure this packet in such a way that after the random application of a whole list of shuffling procedures that are commonly used, that I somehow was able to predict ahead of time the structure of the ending packet. So I'm looking forward to your comments. I appreciate you watching.